Example 3 on page 413. Find all numbers for which the rational expression is not defined. So we need to find what t will make this rational expression undefined. Now, this rational expression is undefined when the denominator t squared minus 3t minus 28 equal to 0. Okay? Now, we need to find what t will make the denominator equal to 0. To find what t that make the denominator equal to 0, we need to solve for it. So let's set the denominator equal to 0 and solve for the t. We want to find what t will make this denominator equal to 0. If we know those t, we can avoid those t, okay? Alright, this is a trinomial, t squared minus 3t minus 28. And we learned in the previous section, we know how to factor trinomials. You should try and attempt to factor trinomial. Alright, I know some case you cannot factor, but you should try to see if it's factorable or not. So we have this trinomial. Now this is review. Ax squared plus bx plus c. Okay, trinomial. A is a coefficient of x squared. So a is in this case 1. B is coefficient of x. For this case, the coefficient of t is negative 3. So that means b is negative 3. And the constant term c, for this case, the constant term c is negative 28. Okay? So b is equal to negative 3 and c is equal to negative 28. Okay? We need to know b and c to factor out this trinomial. Now, let's draw this. Alright, see what happened. This is review, okay? This is pairs of factors. This is sum of factors. Okay, so you know, you want to find the factors of c, okay? Factor of c, so that those factors from c will sum up to make b. Okay? So what is c? C is negative 28, right? So let's find factors of c. It could be negative 1, 28, or it could be 28. You know what? Let's stick with this first. Negative 1, 28, negative 2, 14. Does 3 possible? No, 3 is not a factor of 28. How about 4? 4 times 7, yep. How about 5? 5 times what? You go to negative 28, no. 7. 7 is actually this case, so that's all we have. So we have 3 possible cases. It's actually 6. 6 possible cases, because what if this value right here is positive 1 and this value is negative 28, okay? So what if this value right here is positive 2 and this is negative 14? Or what if this case, this number right here is positive 4 and negative 7, okay? It must have opposite side because c is a negative value. Now let's see the sum of these two factors to see if it's possible to make b. So let's add minus 1 plus 28. Is it equal to b? b, which is negative 3, okay? This is 27. No. How about when a case you have positive 1 and negative 28, so it's equal to negative 27, so still not the case. So you know that these factors of c, okay, are not the factors for the trinomial. Alright, how about this one? You kind of know it's impossible, right, to find the sum of negative 2 and 14 to make b equal negative 3, right? It's impossible. Even when 2 is positive, 14 is negative 14, still cannot make a sum that equal to negative 3, right? So you know that these two factors are not the case. How about this? let's sum up the last one. Negative 4 plus 7 equal to positive 3. It is better. It's close to, right? But it's still not the case because this is positive, this is negative. What if 4 is positive, 7 is negative? Yes, it becomes negative 3. So you know this is the case. Okay, but it's only the case when 4 is positive. So 4 is positive, 7 is negative. Okay? So that means 4 and negative 7 are factors. Let's replace all that's here. So we have t plus 4 times t plus negative 7 equal to 0. Simplify, we get okay. So you know that when t equal to negative 4, we'll make this product equal to 0, right? Because okay, let's solve for this. Let's see. When you solve for this, you would get t plus 4. This is only true when you have the right hand side equal to 0, okay? Equal to 0. Or t minus 7 equal to 0, okay? So I'm solving this. So let me erase this slide. Right? The denominator, okay, the factor denominator right here will equal to 0 if this factor here, t plus 4 equal to 0, or this second factor right here equal to 0, right? Think about if the first factor, t plus 4 equals 0, 0 times anything equal to 0, right? Or another case that when you have the second factor, which is t minus 7 equal to 0, that means it doesn't matter what value in the first factor, when multiplied by a 0, guaranteed is equal to 0. So that means that's what we saw, that when we have the R right here. So t plus 4 times t minus 7 equal to 0 if either the first factor t plus 4 equals 0 or the second factor t minus 7 equal to 0. Alright, let's solve for t plus 4 equals 0 or t minus 7 equal to 0. So t plus 4 equals 0. To solve for t, we subtract 4 on both sides. So t plus 4 subtract 4 is 0. 0 subtract 4 is negative 4. Simplify, you have t equal to negative 4. But don't forget to solve on this side as well. So you have or right here. So to solve for t, you add 7 on both sides. T plus 0 equal to 0 plus 7 is 7. T equal to 7. Okay? So that means these two t's will make this denominator equal to 0. You can test, right? Take t equal to negative 4, plug into here. Negative 4 plus negative 4 plus 4 is what? 0. 0 times anything is 0. Okay? Or when you have t equals 7, substitute t equals 7 to the second factor. 7 subtract 7 is 0. 0 times anything here guaranteed is 0. So you say that thus this rational expression t4 minus 5t, t4 minus 5t divided by t squared minus 3t minus 28 is not defined when t equal to negative 4 or t equal to 7. Okay, these two values, either one of these will make this denominator equal to 0. And this is how you solve it, and this is the answer for this example 3 on page 413.